Okay, so we are doing integration by parts, and this is part 2. And I want to show you a formula that works only with powers of x. So this nice little formula for integration by parts. And it works only when you have powers of x. Okay, say x to the n. Okay, so here's an example. We already know that when you do the integral of x squared e to the x dx, that results in 2 integration by parts problems. Okay, so here's a way to get around it. So notice I have x squared. So I have a power of x. So therefore this particular problem is eligible to use this formula. Samuel, did you cover this in the recitation? Okay. Here we go. You are going to start by making a table. On the left side, you will be taking the derivative with respect to x of whatever it is that you're looking at. On the right side, you will be taking the integral with respect to x. So does everybody see that? Left side derivative, right side integral. Really? So weird how something that does that sometimes. Okay, so the derivative should be something that as you take the derivative goes to 0. So x squared goes here. The derivative of x squared is 2x. The derivative of 2x is 2. The derivative of 2 is 0. So notice I did my table. X squared, 2x, 2, 0. I took all derivatives. Okay, on the other side, I have e to the x. The integral of e to the x is e to the x. The integral of e to the x is e to the x. The integral of e to the x is e to the x. This is an easy one. Okay, now you cross multiply like that. Okay. And the last thing is the first product is going to be positive. The second product will be negative. The third product will be positive, and I don't have to go any further because I have 0. So now I get that the integral of x squared e to the x dx is equal to, the first one is x squared times e to the x. The second one is minus 2x e to the x. The third one is plus 2e to the x, and then I'm done, plus c. Okay, here's the next one. Okay, example 2. So I want to integrate x cubed, the sine of 2x dx. So if I were to do this, this requires 3 integration by parts. I got to take the x squared, the x cubed, reduce it to an x squared problem. Then I have to take the x squared problem, reduce it to an x problem, and then I'm still integrating something. So I have 3 integration by parts. And yes?
Is your screen blank right now? Because I can't see what you're viewing on your screen.
They'll say, I'm sorry, something happened to my Wi-Fi.
Wait, can you hear me?
I can hear you.
I'm saying, is your screen blank right now? Because I'm just seeing a black screen.
Is that what everybody sees?
I have no idea.
Oh, honey, I don't know.
I can see your screen.
I don't know why that's what you're seeing.
It's probably my, I'll figure it out.
Can you go out and come back in?
Yeah, I'll try to do that. I'll be back soon.
Okay. All right, so we're going to do the same thing on this one. We are going to make a table. Remember, it only works with powers of x. Okay. This time, I have x cubed. Oh, this side is the derivative with respect to x of whatever. This side is the integral of whatever. So I'm going to start off with x cubed. Its derivative is 3x squared. Its derivative is 6x. Its derivative is 6, and its derivative is 0. So this is why I was saying to you guys. Oh, by the way, did anybody see the practice integration and derivative pages I put up for them? Okay. All right. Okay. So now's where life gets a little tough because you got to know how to do these antiderivatives. So the function is the sine of 2x. Where did it come from? Well, it came from a cosine of 2x. But if I take the derivative of cosine of 2x, I get minus sine. So that's the first thing. And then it has to have a 1/2 because now when I take the derivative, I get the right thing. So the derivative of minus 1/2, the cosine of 2x, is negative 1/2. And then the derivative of cosine of 2x is minus sine of 2x. But the chain rule says I have to multiply by 2. So yes, the 2's drop out, the negatives drop out, and I get sine 2x. That is the perfect antiderivative. Okay, now we got to do it again. So the cosine of 2x came from a sine of 2x. But when I take the derivative of sine, I get this cosine, so the sine stays the same. So this is negative 1/4 sine 2x. That's the antiderivative of cosine 2x. Okay, what is the antiderivative of -1/4 sine 2x? Well, it's got to be a cosine 2x, because that's the only thing it can come from. When you take the derivative, you get the negative, so that's perfect. But a 2 would have popped out, so I need to make sure I divide by that. So now I get 1/8. And then the antiderivative of the cosine of 2x, well, that thing came from a sine of 2x. The derivative of sine is positive, so that works. So I need to make sure I pop out another 2, so I get 1/16. Okay, so what I did with each step was I found the antiderivative. So here, antiderivative. To go here, I found the antiderivative. To go here, I found the antiderivative. And to go here, I found the antiderivative. So, got to be able to do those. You got to be able to find antiderivatives in, I won't say record speed, but you should be able to find the antiderivatives. Okay. All right, we are going to do the same thing we did before. We are going to cross. So the x cubed goes with this, -1/2 cosine 2x. The 3x squared goes with the -1/4. The 6x goes with the 1/8. And the 6 goes with the 1/16. So we cross diagonal. The first one is positive. The second one is negative. The third one is positive. The fourth one is negative. We don't worry about the last one. It's a 0. So we're done. So now we get the integral of x cubed, the sine of 2x dx is equal to, we're going to start with the first one. That is x cubed times a -1/2 cosine of 2x. Then I'm going to subtract off the next one, which is 3x squared times a -1/4 the sine of 2x. Then I'm going to add on the next one, which is 6x times 1/8 the cosine of 2x. And then I'm going to subtract off a 6/16 the sine of 2x. And then I'm going to squeeze in a plus c. And so now I'm going to simplify this. Cameras on, people, cameras on, cameras on. The integral of x cubed, the sine of 2x dx is equal to -1/2 x cubed, the cosine of 2x. Minus and negative makes plus 3/4 x squared, the sine of 2x. 6/8 gives me 3/4 x, the cosine of 2x. And 6/16 gives me -3/8 the sine of 2x plus a constant.
I have a question.
Yes.
Okay, so whenever you're taking the derivatives on the left side of the chart,
Yes.
do you always start with like positive and negative, positive
Yep.
and negative?
Yep, always. Always positive, negative, all the way down. Yes. So if you get an x cubed something something on the test, believe you me, I am not expecting you to do three integration by parts. I'm expecting you to use the rule for powers of x. Okay. So now what I want to do, this last type of problem, well, there's two types. This is the repeating. I'm going to do two of these. Okay, so the first one is the integral of e to the x cosine of x. So that is the problem I'm trying to solve. Does everybody see that? That is the problem I want. So I'm going to let u of x be e to the x. And then dv has to be everything that's left. That is the cosine of x dx. Okay, so can you please do du and v? So what is du?
It's e to the x itself.
Good. And what is the integral or the antiderivative of cosine x?
Sine x.
Sine x. Okay, so far so good. So now we have the integral of u dv is equal to uv minus the integral of v du. Can you please write that out for me? Please write that out. And tell me what you get.
You want us to tell you what we got?
Mm-hmm.
Oh my God. E to the x sine x minus the integral of sine x times e to the x dx.
Beautiful. Uh-oh. I don't know how to do, I don't know this, do I? Okay. So now we must do this by parts.
So is there a reason why you put the ex first?
Usually, usually the order of writing things are polynomials, exponentials, then cosines and sines. And so because I've been doing it so long, I'm used to writing it like that. I usually put the exponential before the sine or cosine. Okay. I got another integration by parts problem. So this much I know. Uh-oh, that is not true. I am missing the cosine part. Equals uv minus the integral of v du. So I know this. We just found this. I wonder, sometimes I wonder why my system acts up. And I wonder if it's just because I've been using it too much. And it just gets mad with me. Okay. The problem is this is unknown. So let's compute that integral. So now we're going to do the integral of e to the x sine x dx. So we're going to let u equal e to the x and dv equal to the sine of x dx. Find du and v, please. Okay, what's du?
E to the x.
Dx.
Yeah, dx. Yeah.
I'm going to say, don't tell me I forgot my dx on. You gotta be kidding me. Okay, and what's v?
Would that be negative cosine x?
Negative cosine x. If you don't have that negative cosine x, you're going to have a disaster. Okay, write it out. The integral of e to the x sine x dx is uv minus the integral of v du. Write it out. Okay, anybody get an answer?
E to the x times negative cosine x dx minus,
There's no dx.
oh, sorry,
Okay,
minus
keep
the
going.
integral of negative cosine x times e to the x.
There's your dx. Okay. So the integral of e to the x sine of x dx is equal to negative e to the x cosine of x minus a negative makes plus the integral of e to the x cosine of x dx. So now I have now here's what I can do. I was originally trying to solve for this over here. This was my original guy. Oh, Yeah, this was my original guy. I was trying to solve for him. And in trying to solve for him, I got this other integral. So I had to sidetrack myself, solve for the other integral. And oh my goodness, I got that thing back again. So what I'm going to do is I'm going to take my e to the x, this integral right here. This integral. I'm going to take that integral and I'm going to stick it in right up here. Okay. So let's see what we get. So now we get the integral of e to the x cosine x dx is equal to, it was e to the x sine x minus the integral of e to the x sine x dx. But I know the integral of e to the x sine x dx. So now I'm going to put that in. So I get minus negative e to the x cosine of x plus the integral of e to the x cosine x dx. Okay. So now I get e to the x, integral of e to the x cosine of x dx is equal to e to the x sine x minus a negative makes plus e to the x cosine x. And now I get minus the integral of e to the x cosine x dx. Okay, now if this was regular algebra, I'm going to take and add that thing to both sides. E to the x cosine x dx. And I'm going to add the integral of e to the x cosine x dx. So on the left-hand side, what do I get?
Would it be 2 integral ex cosine x dx?
Fine, I get 2 times the integral of e to the x cosine x dx. And what do I get on the right-hand side?
0.
Yep, these drop out. But I still have this other stuff. That's still on the right-hand side. So I still have e to the x sine x plus e to the x cosine x. So now if I want to solve for e to the x cosine x, which was my original problem, I just need to divide by 2. So the integral of e to the x cosine x dx, my original problem, turns out to be e to the x sine x plus e to the x cosine x divided by 2. Okay. Any questions about that? Y'all seem awfully quiet. EJ. That looks absolutely delicious.
How you doing, Professor? You know, this is a
Hi.
nice sandwich right here.
It looks fantastic.
Ain't nothing better than watching the calculus lecture and enjoying a nice meaty sandwich.
I don't even eat meat. I don't eat beef.
Okay.
That looks delicious. Okay.
I have a question.
Yes.
So, when can you do this? Like, add it on both sides and then divide by 2.
You'll know when to do this when your integral by parts repeats with a function that looks like it. So you get a wraparound.
So every time like whenever it repeats itself, you can like you see the same equation. You can
Well,
just divide by 2.
you see a similar equation. You have to take this one and put it in that one. Okay, so think about this. You didn't see nobody where? Okay. Think about this. It's kind of like if you had x plus y plus 2 equals negative x and you were solving for x. You would add x to both sides. And you would have 2x plus y plus 2 is equal to 0. So now you'd have 2x is equal to negative y plus 2. And then you divide by 2. But I did it with an integral instead. So instead of just having an x, I had an integral because they were of opposite signs. I can move that to the other side. I'm going to do it again. I have one other problem similar to it. Okay. Number 3. What example am I at? Oh, number 2 in this. Y'all are my favorite class. Don't tell nobody. Okay, the integral cosine of the natural log of x dx. Now, this one is tough. Okay, this is a toughie. Okay. So the first question I have is, what is u going to be? We're going to do this by parts. So remember, you only have 2 things. You have u and you have dv. And it has to be a case quarter perfect exchange. I'm not giving you a case. I'm not going to give you 15 cents and you give me a case quarter. It's a perfect exchange. So only one thing can be u and everything else has to be dv.
Logan.
So I would say, I would say you will be, it looks like cosine x.
Okay, very close. U has to be the cosine of the log of x. It has to be that whole thing because cosine needs an argument. So its argument is log of x. You can't just say cosine. You gotta have the cosine of something. And it is taking the cosine of the log of x. So that itself is one function. So what is dv?
Natural log of x, dx.
Okay.
It's dx.
Case quarter exchange.
Would it be dx?
It has to be dx. It's the only thing that's left. Okay, everybody see that? Xavier. Okay, I have the cosine of the log of x. That's one term. So the only thing that can be in this problem is a u. And if that's u, this has to be dv. Now, I don't want to switch them because I don't know how to integrate cosine log x. So that can't be dv. That's too hard. So therefore, for this problem, the only thing that could possibly be u is the cosine of the log of x. Do you understand that? Good. Okay. Q, I can't, Shaquel, I can't see your face. Do you understand that? I can't see you. Lawrence?
So Dr. La,
Yes.
I understand.
Good.
so basically, for you, it always has to have a variable, yes? That's the part of the argument, as you were saying?
Well, cosine has to have a variable. You just can't write cosine of something, cosine dx. Cosine has to have an argument.
Okay, yep.
Dr. Love,
And yes,
if it wasn't a problem of integration but just differentiation, would you do, like, for example, like cosine of u and then do 1/x, also, or like if you're doing a differential, it'll be different than integral, right?
guess what, Victor? You gonna do dv, du. Find du, because you just told me what to do. You just told me what to do. So to take the derivative of the cosine, I get what?
Negative sine of
Negative
u
sine,
and of
good.
u.
And then you said I have to multiply by the derivative of the log of x, so I get
1/x times
dx. And that's
dx.
it. That's it.
Okay.
Okay, so you were already thinking it. You just had to pull it together. So when you take the derivative of the cosine of the log of x, you take the derivative of the outside function. So the derivative of cosine is minus sine of whatever the argument is of the u. And then you have to take the derivative of what's inside. So the derivative of the log of x is 1/x, and it's a derivative, so you get dx. Okay, cool. You were ahead of me.
Yeah, I would have never thought of that, actually, because I would
Okay,
have probably done it halfway.
The chain rule.
chain rule. Chain rule. That's exactly what we just did. Okay. What is V?
What is the x? I mean, yeah, x.
V is just X.
Got my hands and stuff on here.
Okay.
Let me see if that's real quick. I don't know if it's dead or not.
Okay, y'all ready to write it out? As they say, call for the question. Call for the question. Call for the question.
It's dead. It's at 0%.
Is there anybody who has no clue how to write it out? This is the time to learn it.
What, hit somebody? Backing out and never.
Okay, who is this? Okay. What daring soul, other than, I'm gonna tell you who can't answer.
Woodwork? Yeah.
Okay, I gotta mute all y'all because y'all being loud. Okay.
Because I was supposed to be broken.
Oh my goodness, who is still talking?
Baseline numbers. Oh shoot, it might be me.
All right, let's see. Tiaja's camera's off. Ray Sean's camera's off. Okay, everybody's muted now. Okay, Tiaja's not muted, but that's okay. She's quiet. Okay, Diara, you can't answer this question. Don't even laugh, girl. You can't answer it. You've been answering.
Dr. Lodge,
Yes.
do you
Tiaja,
hear me?
I can hear you.
Yeah. You hear me?
Yep.
My camera's not off. It says it's on, but I'm dialed in, like through the
Okay,
phone.
that's why. Okay, because you're dialed in. It's okay. I see you.
Okay.
Ezekiel can't answer the question. Neither can Victor. Anybody else can answer the question. Those three people can't answer the question.
Can I try?
Gustavo can answer the question. That's not
Absolutely.
fair.
Okay, go ahead, Maria.
Oh, so cosine of natural logarithm x times x minus the integral of x times negative sine times ln x times 1 over x.
So you said integral of, do the last part for me, please.
The integral of x times negative sin
Sine, go ahead.
ln x times 1 over x
Keep going.
dx.
Yes. Okay. We're rocking. Okay, so now Maria can't answer anymore. I need somebody else.
Like, what's for the next step?
Yep.
Can I answer that?
Who's that?
Juan.
Yes, Juan. That's what I thought. I couldn't see you. Go ahead.
That's fine. I would say the x and the 1x inside the integral would cancel out,
Okay.
just leaving you with the integral of negative sine with a log of x.
Okay, so I get x cosine of the natural log of x. And then what happens to the minus negative?
Minus negative that becomes a plus.
Okay, now does everybody see what happened? Same thing happened as what happened in the last problem. We're getting a wraparound because we got something that looked like the first integral. The first integral was cosine log x. This one is sine log x. They kind of look the same. So now we got to do it again. So now we have to compute the integral of the sine of the log of x dx. Okay, what's u?
Sine ln x.
Okay, that's good. Both of y'all started with the same thing. U is the sine of what?
Of ln x.
Good. And what is dv?
Yeah.
It's dx.
Good. Okay, now I need you to find du and I need you to find v. So I'm actually going to give you a few seconds to finish this integral and get the next block. So I want a block for the sine of x, the integral of the sine of the log of x. So I'll give you a minute. This is a good time to take roll. While you're trying to figure that out. Okay. All right, Juan, I know is here. Dizer, you've been quiet.
Here.
You are here, good. Ayana. Ayana is here, but she's not talking.
Oh, I am here.
There you are, I hear you. Okay, Maria's here. Edward, I saw. Janelle, I saw.
Here.
Gotcha. Logan.
Here.
Okay, Diara is here. Antoine, I saw. Shaquel, I saw. Tiaja, I saw. Gustavo, Cule, Victor, Donye, Alan, Ezekiel, Elisha, let me see. Elisha is here. Malachi,
I'm here.
thank you. Xavier, Maxine, Eric, and Jadeja and Lawrence. We are missing one student. Nope, we are not. Rayshawn is here.
Yeah, I'm here.
Yeah, I think we have actually an entire class. That is fantastic. Proud of y'all. Okay. Did anybody get a formula for me for the sine of the log of X?
Can I answer this?
Is that Diara again? I'll let you answer. Go ahead. Go ahead.
So I
Tell me
got,
what you did.
so after we integrated, we got the U, du, v, dv.
What did you get for DU? What did you get for DU?
I got cosine natural log of x times 1 over x dx.
And what you get for V?
I got x.
Okay, so you got the integral of the sine of the log of x dx is equal to, keep going.
I put okay, so I put x sine of ln x, natural log of x, sorry, subtracted by the integral of x cosine natural log of x times 1 over x dx. And then I simplified it.
Okay.
And then it turned into it then turns into x sine of natural log of x subtracted by the integral of cosine ln x dx.
Okay. All right, there we go. That's the second one. Okay, so now all you need to do is make the substitution going from here into there. Does everybody see what to do?
Could you repeat that again, Dr. Locke?
Okay, so from the first one, we found that the cosine of the natural log of x dx was in terms of an integral of sine. So we found the integral of the sine. Now we just have to put that back in. So go back to what you were trying to solve originally. The integral of the cosine of the natural log of x dx is equal to x times the cosine of the natural log of x plus the integral of sine. The integral of sine is x sine of natural log of x minus the integral of cosine of natural log of x dx. So now I can take and add this one to the other side. So this one gets added to the other side. So now I have two of them. So this is equal to x, the cosine of the natural log of x, plus x, the sine of the natural log of x. And there it is. I can divide by 2. Okay, and it's not always 2. So I'm going to tell you guys, it's not always 2. So I'll give you one to practice, and then you can come back and ask me about it. The integral of the cosine of the natural log of x dx is equal to x, the cosine of the natural log of x, plus x, the sine of the natural log of x, divided by 2, add on my arbitrary constant, and I am done.
Okay, can you tell us why it's 2 in this case, and then why it wouldn't always be 2?
Okay, so let me show you why it wouldn't always be 2. So here's the problem. The integral of e to the 2x cosine of 3x dx. Okay, so I'm going to let u equal e to the 2x and du equal cosine 3x dx. So now du is 2e to the 2x dx. And this should be dv, my apologies. dv, so v is going to be the sine of 3x, and I'm going to need a 1/3 there. Okay, so far so good. So now I get the integral of e to the 2x cosine 3x dx is equal to u times v. So I'm going to get 1/3 e to the 2x times the sine of 3x minus the integral of v du. So that's going to give me 2/3 e to the 2x sine of 3x dx. Okay, v du. Okay. So now I get the integral of e to the 2x cosine 3x dx is 1/3 e to the 2x sine of 3x minus 2/3 the integral of e to the 2x sine of 3x dx. So now I have a wraparound. I got a whole new problem to solve. So now I have to solve for this integral. Okay. So I get the integral of e to the 2x sine of 3x dx. So u is e to the 2x and dv is the sine of 3x dx. So du, again, 2e to the 2x dx, that was nice. And v minus 1/3 the cosine of 3x, because when I take the derivative of the cosine of 3x, a negative pops out and so does a 3. Okay. So now the integral of e to the 2x, the sine of 3x dx, u times v, negative 1/3 e to the 2x cosine of 3x minus the integral of v du. So that gives me a 2/3, and it's negative e to the 2x cosine of 3x dx. Okay, so all I've done that's different than the previous problem is I've been throwing around some 2s and 3s. Okay, because we got derivatives of 2x, 2, and integrations bring out 1/3. Okay, so that's what I have as an integral. Okay, so now this gives me that the integral of e to the 2x sine of 3x dx is negative 1/3 e to the 2x cosine of 3x. Minus a negative gives me a plus, 2/3 the integral of e to the 2x cosine of 3x dx. There's my wraparound. So now here's the second integral. And now I need to do the same thing I did before. I need to take this and plug it in there. Okay, anybody that does not see what I'm doing? Okay. So now I get the integral of e to the 2x cosine 3x. Dx is equal to 1/3 e to the 2x sine 3x. And then I have minus 2/3 of the next integral. So the next integral is negative 1/3 e to the 2x cosine 3x plus 2/3 the integral of e to the 2x cosine 3x dx. So I took this whole thing, come on now, get yourself right. I took this whole thing and plopped it right in here. Okay. So now I get the integral of e to the 2x cosine of 3x dx is 1/3 e to the 2x, the sine of 3x minus. So now I have a negative 2/3 and a negative 1/3. So that's going to give me a positive 2/9 e to the 2x cosine of 3x. And now I'm going to subtract off 4/9, the integral of e to the 2x cosine of 3x dx. And this is why I said it will not always be 1. So now I don't have one of them to add to the other side. I have 4/9 of them to add to the other side. The 4/9 came from the 2/3 times the 2/3. So now I'm going to add 4/9. So now I'm going to have the integral of e to the 2x cosine of 3x dx plus 4/9. The integral of e to the 2x cosine of 3x dx is equal to what's left. 1/3 e to the 2x sine of 3x plus 2/9 e to the 2x cosine 3x. So now I have to add these together. I have one of them plus 4/9. So that gives me 1 plus 4/9 times the integral of e to the 2x cosine of 3x dx is equal to that right-hand side. So that's the same right-hand side. But now over here, I get 1 plus 4/9, so I get 13/9. The integral of e to the 2x cosine of 3x dx again is equal to that same right-hand side. So now I have to multiply by 9/13. So now I get the integral of e to the 2x cosine of 3x dx is equal to 9/13 times 1/3 e to the 2x, the sine of 3x, plus 2/9 e to the 2x cosine of 3x. So when all is said and done, I get the integral of e to the 2x cosine of 3x dx. So the first one, I'm going to multiply everything through by 9. So I'm going to get 1/13. Wow. 1/13 3 e to the 2x sine of 3x plus 2 e to the 2x cosine 3x plus my little trusty constant. I'm done. So when other numbers pop out, it gets hard. Okay. So far, so good. I know that was a toughie. That's going to take a minute to digest. Go
Dr.
back
Lott,
over the video, you'll be good.
Dr. Lott,
Yes.
where when you were, I think it was the fourth to last step, or it was when you have 1 plus 4/9
Yes.
times the integral. Where did the 1 come from again?
Okay, so there is right here. The coefficient of this is 1. So if I had 2 of these, I would have had 2 plus 4/9. But it's only one of them. So I just have 1. So I factored out the 3. I factored out the integral, and that left a 1 plus 4/9.
Okay. Okay, so you just separate the values and then you're able to get 1 plus 4. Right?
Mhm.
Okay,
Yeah,
thank you.
no problem. Okay. Tomorrow, I'm going to start a little bit of this now. This class ends at 2:45, right? I got 8 minutes. Okay, we can work with that.